Alright, hello. Welcome to the second tutorial video on integration. Okay, so in this video we talk about techniques of integrating polynomial functions. Okay, so straightly you are dealing with what? Polynomials. Okay, and the first technique we talk about is the substitution method. Okay, so I have some simple thing here that I want to show you. If you want to find the integration of a specific function using the substitution method, then what you have to do is that first you need to make sure that there are the product of two functions. It can be fractional functions, it can be just product of two functions in a linear form. Okay, like I have here. It's not always that you see them in a linear form like this. Sometimes it can be a fraction. Okay, then you let u be equal to the one with the highest power that you think it will cause confusion in the integration. Then you find du dx if only the du dx can be a function of g of x, so that you come and cancel it. Okay, if only this is possible, then you use what we call the substitution method. Okay, so check these conditions always, so that once you change the variables to u, everything will be in u. So from here, from this side, you could see that dx is actually equal to du over g of x. Okay, so that putting this back into this will come and cancel g of x, and we'll be left with u to the power n. Okay, so that is the basic definition for it. So using the substitution, you're just trying to change the variable from x to a certain variable u. Okay, so now let's go and work some more examples and you would understand what I'm trying to mean. Okay, all right, so now the first question all right, so it's somehow tedious, but then we'll learn to go about it. Okay, actually the substitution method is just to simplify or make your work more simpler. Okay, but here if you look at it clearly, let's say our g of x comparing to what we did is equal to 4x, and now let's say f of x is actually equal to 2x minus 1. But now if you consider these two, when you differentiate any of them, you won't get back any of these functions. So how do I go about it? All right, so it's not always that your substitution rule that I stated before will work. Sometimes you need to manipulate it a bit. Okay, so if you let u be equal to 2x minus 1, then du dx will actually give us 2. Okay, if that is the case, then dx, making the x the subject, will give us what? Du over 2. So now let's come back and put it in the equation. Okay, so or in the integral problem, we have 4x into u, the whole of this is u to the power 4 dot du over 2. Okay, now the whole of this will give us 2 goes into 4 how many times, because they are just multiplying, so 2 can take 2 out from the 4. Okay, so we get integral of 2x then u to the power 4 du. Okay, now the x in this question or this problem is also a case. Okay, by looking at this side, let's see, we have 2x here, but I can make 2s the subject from this side that I first said. Okay, and in terms of u. Okay, so from that side we know that u is equal to 2x minus 1, then u plus 1, I'm just making 2s the subject, is equal to 2x. So actually 2x is what? U plus 1. Okay, so I come and put u plus 1 there, and this will give me integral of u plus 1 times u to the power 4 du. Okay, and now everything will change back to integral of u to the power 5 plus e to the power 4 all du. So now this changes back to the normal thing that we started with. Like if you have integral of x to the power 6 or x to the power 7 plus x to the power 8 or dx, then you apply your basic rule. Okay, So now let's apply our basic rule. This time the variable we are dealing with is what? U. That is why we are integrating with respect to U. So let me clean some parts. Okay. So with the help of the substitution rule, the whole of this integral has transformed to u to the power 5 plus u to the power 4 all du. Okay, so what you do is just take one of them, integrate it, add it to the rest, and the integral of the other. Okay, since they are just being separated by either addition or subtraction, this will work. Okay, so I have u to the power 5 plus 1 over 5 plus 1. Okay, then plus u to the power 4 plus 1 over 4 plus 1. Okay, then plus c, all of them. So now this will give me 1 over 6 u to the power 6 plus 1 over 5 u to the power 5 plus c. So now what we do is the final answer will be in terms of x, because the question was given in terms of x. Okay, so we just put wherever you see our u in our final answer, I put x back, the representation of u. Okay, u is equal to, from here, from this side, u is equal to 2x minus 1. So I put 2x minus 1 there, and to the power 6 plus 1 over 5. I put 2x minus 1 to the power 5 here plus c. So simply this becomes our integral. Very simple, right? Okay, so let's go and look at the other questions and you would understand more. Okay, alright, so with this question, how do you go about it? Okay, so if you say that our g of x is equal to x and our f of x is equal to 4 minus s squared, then how are you going to do this? Okay, with this, if you could see, the differential of f of x will give you something x. Okay, that means the power of g of x is obtained from the differential of f of x. Then you can apply our substitution rule. Okay, so if you let your u be equal to 4 minus s squared, then my du dx will be equal to negative 2x. Okay, so this implies that our dx is equal to negative du over 2x. Okay, I'm just making the x the subject from the differential of u with respect to x. Okay, you can always go through the change of subjects step by step, but I believe that by now you know how to do change of subjects. Okay, so with this, we come back and put the whole of our substitution in the integral. Okay, so this is an u to the power negative half. Alright, let me write the power well. Okay, negative 1 over 2, then times du ds is now negative du over 2x. Okay, now this means that we can get something like this. The negative will affect everything, so integral of negative x u to the negative half times du all over 2x. Okay, now this x can take this s out, so this cancels this, and we'll be given, or we'll be living with negative. One thing about integration is that if you have a constant, you can push the constant out of the integral sign. Okay, so negative 1 will come out, then we get e to the negative half over 2 du. Okay, so now everything has been simplified to just u. Okay, so negative, I'm pulling the half out. I hope you could understand this. It's like u to the power negative half over 2 is the same as 1 over 2 times u to the power negative half. Okay, now I can put the 1 over 2 out, so that we can get a simplified form of our different integral. Okay, so let me clean some parts and continue with the integration. So negative half the integral of u to the power negative 1 over 2 du, right? So this will be equal to negative half times whatever integral that we'll get. So this is u to the power negative half plus 1 over negative half plus 1 plus c. Okay, hope this is okay. So this is how you do. Let me erase this side. I hope you understand the substitution we did. Okay, alright, so we have this integral will be equal to, I'm just writing this to the top, negative half, then u to the half, okay, this over half as well, okay, plus c, and this whole half here can take this half out, so you get something like negative u to the power half plus c. And what was our u? Our u is what we said, we let u be equal to 4 minus s squared. Okay, so we put our u back, negative 4 minus s squared all to the power half plus c. Okay, and this can be negative square root of 4 minus s squared plus c. This is very, very simple, right? So that is it for the integration. Okay, alright, so with this question above, you can see that there's a square root sign here. Okay, so one thing that we can do is just this, you can say that g of x is actually equal to 1 since it's a 1 times something. Okay, now f of x is equal to ax plus b. So here the only thing we can do is we let u be equal to ax plus b. Okay, then our gu dx will actually be equal to a. Okay, so making dx the subject here, we get dx be equal to du over a. Okay, now if that is the case, then we can put our u back. Okay, so we have something like integral of square root of u dot dx is what, du over a, and this will give us integral of 1 over a square root of u du. Okay, we can interchange just the denominator like that since they are just multiplying. Okay, so this is 1 over a integral of square root of u du. Okay, so this is what we are about to do. Okay, everything has been transformed to 1 over a integral of square root of u du, but this is the same as 1 over a integral of u to the half du. Okay, so this will give us 1 over a out, u to the half plus what, 1 over half plus 1 plus c. Okay, so now this whole thing has been transformed into this, then half plus 1 is 3 over 2. Okay, so u 3 over 2 over 3 on 2. Okay, plus c, and this is the same as 1 over a times 2 over 3, then u to the power 3 on 2. Okay, plus c. If you know how to manipulate your fractions very well, this is what you get, and this will give us 2 over 3a, then u to the power, u is what, ax plus b, that is what we did, then to the power 3 on 2 plus c. This can be your final answer, or if you know how to play with indices very well, then this is the same as 2 over 3a, then the square root of ax plus b or q plus c. Okay, so you can also manipulate it and get something like this. So that is it for the third question. Okay, so let's continue with one more example, and I know you'll be okay, you'll be strong in integration by substitution. Okay, so with this question, I hope you can do that because it's the same as it's just that this time our square root is down there, and if you substitute u to be as plus b, the same thing will happen, just that the power will now be in terms of negative. Okay, so kindly do this and then comment on the comment section below, and then tell me if you were able to do it. If you weren't able to do it in our next exercise or in our next tutorial video, we'll solve it and continue from there. But I know you can use the idea from here, from this side, to solve this. Okay, so let's continue with the fifth one. Alright, so with this, it's very simple, right? Because if you could see this, sorry, there is a mistake in this. It's just ds over that, because with a ds, 1 over square root of 1 minus x is the same as ds over that. Okay, alright, so this is simply the same as integral of 1 over square root of 1 minus x dx. This is what I mean. Okay, so with this I can simply just do some substitution here. If I let the same thing that we did before, u be equal to 1 minus x, then our du dx wouldn't change anything. Okay, becomes -1. Okay, this means that our dx is equal to negative of du. Alright, this is very simple. Okay, so like I said, if you don't remember the way you change subjects, please work on your change of subject, because in the substitution you have to use every technique that you know in mathematics. Okay, so the whole of this integral will transform into 1 over square root of u, then the x is what? Negative du. And like we said in the other example, we said you can factor a -1 out, then 1 over square root of u du. Okay, but you know that square root of u is the same as u to the power half. Okay, and this from indices will give us integral of, sorry, this is minus, there's a minus here, and this will give us negative integral of what? U to the negative half du. Okay, so this is what we are about integrating. Okay, so let's try to clean and get some space and integrate it very fast. Okay, alright, so with this we say that we are just integrating only this u negative half du. Okay, so negative of, okay, then u negative half plus 1 over negative half plus 1 or plus c. Okay, this will give us what? Negative u to the half, because negative half plus 1 is like that, over half, plus c, and this is equal to -2 u half plus c. Now what is our u? Our u is what? 1 minus x, then half plus c. Okay, and this will be our answer, or you can change the half to square root. Okay, so thank you for watching this video, and if you are interested, you like the video, just like and comment on the section, in the comment section, that yes, this is very interesting, and if it has helped you, or if it has helped you a lot, then kindly subscribe to my channel for me, so that we can get into more interesting examples of integrations. Okay, see you next time. Next time we talk about partial fractions, integration using partial fractions. Okay.